My name is Hesham. I'm leading the digital twin and built environment sector with ESRI, Saudi Arabia. I'm glad to be here today in the Gemini Call with the Digital Twin Hub to discuss more components or more enabler of building a digital twin. And as you already know, that digital twin is a system of systems, and it has a lot of components. And especially when it comes to a city scale digital twin, it consists of tens of systems, maybe hundreds of data formats. So today we will shed a light on one component, which is the integration between BIM or Building Information Modeling and GIS, which is Geographic Information System. So BIM basically is a design format in oversimplification. So it's a 3D design format that keeps the information of the structure of each element, and it's aware of the spatial relationships between different elements in the same structure. As well, it helps the designers to have a centralized design between different disciplines to make sure that there is no clashes between the different designs between these disciplines. And GIS is basically a framework for collecting, analyzing, managing, and sharing location data. So everything has a location, and when it comes to city or built environment as well, it's the same thing. Everything has a location. So to create what we call a geospatial digital twin or a GIS-based digital twin, including the BIM information, you need to start with a base map. Base map it provides a richer context to have a deeper understanding of the real world. It's like a background map for the project or for the data that you will create. So you can start with very primitive geometries like points. So points is for modeling the real world asset that could be a metro station, like what we see here. It could be the location of something. It could be a location for some location that you want to go to. It could be tree, it could be some sign in the street. So this is the very primitive shape of modeling a real world asset. Then the linear assets, like so we can model linear assets using lines. It could be metro railway. It could be central line of a road. It could be subsurface utilities, electrical utilities, or water, or whatever. Then the elements that we are interested in, its areas. So we use polygons. It could be used for symbolizing, as we see here, zoning boundaries or project boundaries. It could be building footprint or parking area. So now we have three primitive shapes of symbolizing the real world assets. Then now we have a GIS model. So we can now ask some questions so the GIS can help us to answer. So it could be something like what parts of the city don't have a station, metro station within a 15-minute walk. So we can ask this question for the GIS, and using a workflow of geospatial analysis tools, we can have an answer. So it can highlight for us the neighborhood that is more than 15 minutes walk from the nearest station. And this is how GIS can help us to solve a city mobility related problem. The question could be how many buildings fall within 1,000 feet of a metro line. So we can utilize another way of spatial analysis, which is a buffer. So we can use this buffer, as we see here in orange, around the metro lines to calculate the number of intersecting buildings. And here's the answer. So you can have the number and the location of the buildings within 1,000 feet from the station. So this is how the GIS implies the real world or model the real world in a layer-based view. And these layers could be 3D as well. So you can you utilize or leverage the 3D base maps of the world, and you can add your project as well in 3D formats. So if you have now the primitive shapes and the 3D, you can add as well the design format. We are talking about built environment and the city. So we can add a design format like CAD or the the most advanced shape of design for the built environment now, which is BIM, or Building Information Modeling. So now you have the BIM model in context, so you can make your design in context to be aware of the surroundings. It could make like something like clash detection, but with the surroundings, not with the design elements. So you can make sure that you're building in its right location and it's not exceeding or violating any city regulation. Having a BIM model, it helps us to have federate multiple models, to federate multiple models in common environment. We're talking about city, and we need to make it a foundation to build a smart city. So we can visualize a portfolio of projects and understand how they are related and what is the relationship between these different structures. And having the GIS and BIM data in one place, it could be as well blended with the reality capture information. So we can process the data gathered from drone, LiDAR, or satellite image to have this attractive 3D mesh. So we have to give us a sense of reality and sense of real world, to have our to make sure that our design it's in context and it matches with what is really happening in the real world. And it's not just about visualization. Having this BIM models, it contains its information as it is in home environment, in the BIM environment. So whenever you click on any element of the building, you can see the information like it's in the BIM authoring tool. And having all of this information in one place, all of these geometries in one place, can be used to create interactive visualizations. It could be visualized on web browser, or it could be shared to be visualized on VR experience or AR experience. And extending the power of integrating BIM and GIS from design in context, we can use the indoor mapping. So we have the indoor spaces from the BIM, so we can create what we call floor aware maps. So we have the 3D maps, the floors from the BIM, and now we can deal with it like how we deal with the maps for outdoor. So we can choose a certain location, and it can help me to navigate from place to place. So it's like wayfinding, or you can even utilize your mobile device to do indoor navigation inside the building. Yeah, regarding the question, this is actually an actual implementation for what we really implemented in our campus in Redlands as well. Volks Whistles, and Volks Whistles is created and initiated. It's a leading construction company, and the idea of integrating both BIM and GIS for such a company in its size to have a single source of truth for the infrastructure for the whole city. So whenever they initiate a new project, they have information from the existing structure, or for the to be considered in the new structure on the new projects. And of course, on top of this, you can create, you can get insights from different sources, as you can see here in this actual implementation from Volker Whistles.
And seconds left, if that's okay.
Yeah, I will. This is the closing. So I want to close by quote of the information manager of Volcker whistles using this integration between GIS and BIM. Now we can have everything more accessible, including BIM models, Quanti Cloud, and GIS information in one system and really at our fingertips. Thank you.
So Hesham, the first question for yourself is, a lot of your examples were simulations / models to deliver analysis. How do you achieve the synchronization / connection to the real world to enable better analysis as part of being a twin?
Okay, thank you. I believe the first question and the second questions are the same. Yeah, we're talking about the BIM and GIS integration as an enabler for creating a digital twin. So we just focused on the data layer of the city digital twin, and what we are proposing is having these two data formats in one place to have an aggregate model of the physical assets from the outdoor and the indoor. Then we can add the other layers. It could be other types of simulations, or it could be real-time connection with this data. So this is just the data, one piece of the data layer pieces, if we can say like that, or one layer. So it's the data layer containing the GIS and the BIM to have the foundation for future simulations or future integration with synchronizing technology.
And our final question, Hesham, for yourself is, how do you manage the information source differences and models between BIM and GIS? Do you have a foundation model to enable that analysis?
Okay, as I understand the question, yeah, this was very challenging to have different data sources in one place before, but fortunately now that the technology nowadays, it allows us to have these different formats in one place. And if you're asking about the foundation model, actually it's the traditional GIS. So you just have the traditional digital map that you are familiar with, but now it's open to digest or to contain different data sources, including BIM or 3D formats from LiDAR, drones, or satellite images.